Mars. The very name evokes a sense of wonder, a celestial neighbor, shrouded in mystery and possibility. Its reddish hue has captivated humanity for millennia. Today, our fascination with Mars has only intensified. It has transformed into a tangible destination. Our robotic emissaries send back images that ignite our imaginations. We see a world sculpted by ancient floods, with towering volcanoes and canyons. Mars represents a challenge, a frontier beckoning us. The question is no longer if, but when will humans set foot on its surface? Join us now on a journey to the Red Planet. Imagine standing on the surface of Mars. The ground beneath your feet is a rusty orange, littered with rocks and dust. The sky above is a pale pink, the thin atmosphere scattering sunlight in a way we never experience on Earth. The air is thin and cold, the silence broken only by the whisper of the wind. Mars is about half the size of Earth, with a surface area roughly equivalent to all the continents combined. Its gravity is weaker than ours, so you'd be able to jump higher and objects would weigh less. But don't let its smaller stature fool you. Mars is a world of extremes. It boasts the largest volcanoes in the solar system, including Olympus Mons, a behemoth 3 times taller than Mount Everest. Valles Marineris, a canyon system so grand it makes the Grand Canyon look like a ditch, stretches across the Martian equator. These features are a testament to Mars's dynamic past, a time when volcanoes raged and ancient floods carved channels across its surface. Our journey of discovery began in earnest in the 1960s. The Mariner missions, launched by NASA, provided our first close-up glimpses of Mars. These robotic explorers beamed back images revealing a cratered and barren world, challenging our preconceived notions of a habitable planet. Then came the Viking missions in the 1970s, the first successful landers on Mars. Viking 1 and 2 touched down on the Martian surface, capturing panoramic images and conducting experiments to search for signs of life. While the results were inconclusive, they paved the way for future missions and ignited our collective imagination. In the decades that followed, a flotilla of spacecraft from various nations have orbited Mars. They have mapped its surface in intricate detail, studied its atmosphere and geology, and even peered beneath its surface using ground-penetrating radar. These missions have revealed a planet more complex and intriguing than we could have imagined. They have found evidence of past water, suggesting a time when Mars may have been warmer and wetter, perhaps even capable of supporting life. While orbiters have provided invaluable data from above, it's the rovers that have truly captured our hearts and minds. These robotic explorers, equipped with cameras, drills, and scientific instruments, have become our eyes and ears on the Martian surface. Sojourner, Spirit, Opportunity, Curiosity. These names have become synonymous with Martian exploration. Each rover has built upon the successes of its predecessors, venturing farther, exploring new terrains, and making groundbreaking discoveries. Who can forget the twin rovers, Spirit and Opportunity, landing on opposite sides of Mars in 2004? Their mission was planned to last just 90 Martian days, but they defied all expectations. Spirit roamed for 6 years, while Opportunity continued its explorations for an astonishing 15 years, sending back a treasure trove of data. Today, Curiosity and Perseverance continue to explore the Red Planet, searching for signs of past life and paving the way for future human missions. Their discoveries, from ancient lake beds to organic molecules, fuel our excitement about the possibility of life beyond Earth. Section 5. The atmosphere, thin air, and dusty skies. The Martian atmosphere is, well, a far cry from Earth's life-sustaining blanket. It's incredibly thin, about 100 times less dense than our atmosphere at sea level. This means you wouldn't be able to breathe on Mars without a spacesuit, and the lack of pressure would cause your blood to boil. The air is composed primarily of carbon dioxide, 95%, with trace amounts of nitrogen, argon, and oxygen. Not exactly a recipe for human respiration. And while the sky may appear a pale pink during the day, sunsets on Mars are a muted blue, a consequence of the way dust particles scatter light. But this thin atmosphere doesn't mean Mars is devoid of weather. In fact, it experiences dust storms that can engulf the entire planet. These storms are driven by solar heating, which creates winds that whip up the fine Martian dust. These dust devils and storms can last for weeks or even months, posing a challenge for future human missions. The dust can clog machinery, reduce visibility, and even block out sunlight, impacting power generation from solar panels. Section 6. Water on Mars, Signs of a Liquid Past. One of the most exciting discoveries has been the confirmation of liquid water on Mars. Scientists have found evidence of flowing water in the past. Orbiters detected signs of hydrated minerals in Martian rocks. Rovers found ancient riverbeds, lakebeds, and possible shorelines. Mars may have once been a much warmer and wetter place. Recently, scientists discovered evidence of subsurface water. Ground-penetrating radar detected a large saltwater lake beneath the South Polar ice cap. This raises the possibility that life may have existed there billions of years ago. Section 7. The Challenges of Mars, a Hostile Planet. While the prospect of exploring and even colonizing Mars is undeniably exciting, it's crucial to acknowledge the significant challenges that lie ahead. Mars is a harsh and unforgiving environment, hostile to human life in many ways. The thin atmosphere offers no protection from the sun's harmful radiation, and the lack of a global magnetic field like Earth's exacerbates this problem. Temperatures on Mars fluctuate wildly, plummeting to -200 degrees Fahrenheit at night and rising to a balmy 70 degrees Fahrenheit at the equator during the day. The lack of breathable air, the extreme temperatures, and the constant bombardment of radiation mean that humans on Mars would need to live in enclosed habitats, venturing outside only in specially designed suits. Food production would be another major challenge, requiring innovative solutions like hydroponic farming or the development of Martian greenhouses. Then there's the psychological toll of living on a distant planet, millions of miles from Earth. Isolation, confinement, and the lack of familiar surroundings could take a heavy toll on even the most well-adjusted individuals. Section 8. Colonizing Mars, a dream within reach. Despite these challenges, the dream of colonizing Mars persists. The human spirit of exploration, our innate desire to push the boundaries of what's possible, drives us to seek new frontiers and establish a presence beyond our home planet. So how do we turn this dream into a reality? It will require a concerted effort from governments, private companies, and individuals from all walks of life. We need to develop new technologies, overcome engineering hurdles, and invest in research and development. One of the biggest challenges, of course, is transportation. Getting to Mars is no easy feat. It requires powerful rockets, precise trajectories, and a journey of several months. We need to develop more efficient propulsion systems, reduce travel time, and ensure the safety and well-being of the crew during the long voyage. Once on Mars, we'll need to establish a sustainable presence. This means creating habitats that can protect us from the harsh environment, generating our own food and water, and developing ways to utilize Martian resources. Section 9. Building a future on Mars, habitats, and technologies. Imagine a future where humans live and work on Mars. They reside in pressurized habitats, shielded from radiation and extreme temperatures. These habitats could be built underground, utilizing Martian regolith for insulation, or above ground, with inflatable modules covered in a protective layer of Martian soil. Advanced 3D printing technologies could be employed to construct habitats and infrastructure using local materials. Robots controlled remotely from Earth or by Martian colonists could assist with construction, exploration, and resource extraction. To sustain a human presence, we'll need to develop closed-loop life support systems that recycle air, water, and waste. Hydroponic farms, illuminated by artificial sunlight, could provide fresh produce, while algae farms could generate oxygen and supplement the food supply. Power generation will be crucial, and solar panels, while less efficient on Mars due to the distance from the sun, could be supplemented by nuclear power or other advanced energy sources. Water extraction from subsurface ice or hydrated minerals will be essential, and researchers are already exploring ways to create breathable oxygen from the Martian atmosphere. Section 10. Conclusion. The Martian frontier awaits. Our journey to Mars has only just begun. From the early glimpses provided by Mariner to the groundbreaking discoveries of Curiosity and Perseverance, we have learned so much about our celestial neighbor. Yet Mars still holds countless secrets, waiting to be unlocked by future explorers. The challenges of colonizing Mars are daunting, but not insurmountable. With our collective ingenuity and determination, we can overcome these obstacles and establish a permanent human presence on the red planet. Imagine future generations gazing up at the night sky, not just at a red dot, but at a beacon of human achievement, a testament to our indomitable spirit. The Martian frontier awaits us, beckoning us to explore, to discover, and to create a new chapter in human history. The next giant leap for humankind is within our reach. Let's dare to dream big and make the red planet our next home.